This is Greg Troutline with Maritime Reporter TV, and we're very pleased to be joined today by Jim Patterson, the Marine Executive Consultant for Mercy Ships, to discuss the recent delivery of Global Mercy, the world's largest civilian hospital ship. Jim, to start, can you give a brief biography with insights on your scope of responsibilities with Mercy Ships?
Okay, Greg. Yes, pleased to meet you too. We were, I joined Mercy Ships a long time ago, about 34 years, almost to the day. We joined our first ship. I'm a marine engineer by background. I soon became chief engineer. We served on board that ship for 8 years. And then it was time to move off. We had 3 kids getting older. Cabin wasn't getting any bigger, so we moved ashore to here in East Texas, where our headquarters are, and we started our Marine Operations Department. Prior to that, we did everything from the ship itself. We organized our dry dock, spare parts, everything else. It was quite complicated back then, as there wasn't such a thing as email. We had to do everything by fax, and of course the fax number changed quite regularly. So we established the Marine Operations Department here. Of course, we grew along with the industry in terms of the requirements, ISM code and everything else. We did some upgrades on that ship, put in new generators, one thing and another, restored the air conditioning, but it was getting an old ship. It was time to look for another one. We actually had 2 smaller ships join our fleet in the meantime, but we needed to replace the big one. So we started the search. We found a retired rail ferry in Denmark. We purchased that and did a big conversion in the UK, which took longer than we expected. We put that ship into service in 2007. And then already we started to dream about, we needed another ship. At that point in the conversions, we were quite good at knowing the pitfalls of conversions and what not to do. So we decided to dream about a new ship. And we were back and forward on that for a while before finally, I think 2010, our board decided that it was okay to go ahead and pursue a new ship. We teamed up with Stena RoRo, who are used to building ships. We were used to operating them and converting them, but we'd never built a new ship. So we started then at that point to look at what it would take to build a new ship. So we built this ship in Tianjin, China. Once we had completed the tender specification, our broker friend, Gilbert Walter from BRS, sent the package out to about 12 shipyards around the world that he considered were best suited to build a ship like this. Everything from Finland, Germany, France, Croatia, Korea, Japan, and several yards in China. And of course, from a price point of view, China was hard to beat. So the ship was built in Xingang shipyard in Tianjin in China.
Excellent. So Jim, I'm certain that many people watching this know the Mercy Ships name already, but can you just give us a by the numbers look at Mercy Ships today, the organization, the fleet, and its mission?
Yeah, so right now we've got 1 operational ship. The new ship is on its way to becoming operational. She's actually en route from China to Europe. The ship is complete in all respects, certificates and everything, but the hospital itself, although it's built and the major equipment is on board, all the small pieces of hospital equipment still need to be loaded in and fitted up and made to work. We also did have a problem in China, of course, with travel and visa restrictions and so on. We never managed to finish our IT system. So there's a lot of work still to do there. But basically, once this ship comes online and works with Africa Mercy, we deliver healthcare services to the countries that need it most, and primarily those happen to be in West Africa. We work with the Ministry of Health. We have an advanced team that will be there several months before the ship arrives, and we train as the primary focus. Obviously, the individuals who have surgeries on board benefit from that, but the main impact is training the local healthcare workers, all the way from the surgeons to the administrators, including biomed techs and nurses and so on, to improve. They all want to improve. Many of them actually leave their country and come to the US or to Europe or China to improve, but many of them don't go back. And that's a shame because they're really needed at home. So if we can train them on location That's the goal. We're trying to work ourselves out a job so that they can take care of themselves, but I'm afraid that's going to take quite a few years. So that's what we're all about.
Jim, obviously we're here to talk about the ship, the new ship, Global Mercy. Can we give really kind of do a deeper dive on that, a by the numbers look at the ship itself?
Yeah, so the ship, as I mentioned, we had been dreaming about one since we took the delivery of the Africa Mercy from the conversion. One of the things we had to look at was size. What's the appropriate size for a ship like this? You want something big enough that it can be useful as a platform to put a hospital on board, that can provide all this training and services that we've been talking about, but not too big that it's going to take up too much space. Africa is developing. The ports are extremely busy, and we need a space we tend to like to stay there about 10 months at a time. So we came up with this size based on our research, the sort of maximum size that could fit in most ports where the need was. So the ship's 174 meters long, 28.6 meter beam, 6.4 meters maximum draft. So that allows it to go into quite a wide number of ports where the need is, and at the same time not take up too much space. She's 12 decks, gross tonnage is getting on for 38,000, 37,800 and something, if I remember right. So it's a big volume and a relatively short length. So that allows us to have a 7,000 square meter hospital on board, 6 operating rooms, 102 beds, normal beds in the wards. Then we have 90 what we could call low care beds. That's for people sort of pre and post-op that don't need nursing care. And we try to do everything else on the ship. We have patients that come on a daily basis for eyes and some of the simpler surgeries, some of the more complex ones. They can be on board 3, 4, 5 weeks, depending on the recovery. The ship itself is diesel electric because we do spend such a long time tied up alongside. We want to maximize the installed power plant, so we rotate the generators through on a regular basis. We use ABB pods for propulsion. The ship was designed by Delta Marine of Finland. They put quite a bit of time and effort into refining the hull shape for a 12-knot service speed. So the amount of fuel that we use to actually push the ship through the water is quite small. The biggest electrical load actually is the air conditioning. The air conditioning is probably the most complex part of the ship. This day and age of virus transmission and so on, it's full 100% fresh air. But to try and keep it efficient, we use enthalpy wheels to recover the heat that's going out to cool the air that's coming in. The hospital also requires positive, negative pressures, of course, to control the airflow from clean environments to dirty environments, so-called dirty environments from a bacteriological point of view. But otherwise, the ship is pretty much like any passenger ship, ro-ro ferry in terms of the construction. Nothing too complicated. We do have quite a sophisticated waste management system on board, of course. Theoretically, our discharge from that ship would be some fresh water once the sewage is treated, and some ash from the incinerator. Everything else is boiled down to those two components. Of course, we still have the exhaust from the generators. We decided to stick with the burning ultra low sulfur diesel, keep it as clean as possible. That could change in the future, of course. One of our biggest challenges at the moment is availability of some of these alternative fuels. In West Africa, there's not a lot to choose from, so we're stuck with diesel for the time being. The ship can burn different fuels. Works on the main engines, ABB generators, self-tensioning winches. We do have a couple of large cranes for lifting our supplies on and off. We can lift up to 31 tons. We send containers, a couple of containers every month to keep the hospital going, and of course supply food. And we can lift those on board and empty them ourselves.
Jim, as you know, all ship construction projects are unique. And as we understand it, this is the first new ship construction project for Mercy ships. Can you go into detail from design to delivery, how this ship differs from a traditional shipbuilding project?
Yeah, actually, there's not too many differences, although I already mentioned that she's designed for a service speed of 12 knots, which is quite slow for most ships, but we're usually not in a hurry to get there, and we wanted to save fuel as much as possible. But I think the most complicated aspect of this ship was we were the first ship built to international class in China of this type. Nobody had ever done this before over there. It's a completely different concept from building bulk carriers, tankers, container ships, and so on. I mean, starting with the plate thickness, for example. Passenger ships, ferries, and ours are built very thin steel plate. And the shipyard had to learn new welding techniques so that the plates didn't buckle when they were welding them. We were blessed to have a senior surveyor from Lloyd's who had quite a bit of welding experience, and he actually taught the shipyard how to weld thin plate without buckling it. So the shipyard were very grateful for that. And after the first couple of blocks, I've heard people comment, you couldn't get blocks better than this in Europe. The other challenge we had, of course, we were right at the cusp of safe return to port. We had to comply with safe return to port in its early days. And actually set us back quite a bit on the design period, especially having this slow service speed. The safe return to port, if you remember, they say you have to have an advised speed of 6 knots in Beaufort Force 8 if you lose half your propulsion. Well, if you only have 12 to start with and you're trying to do 6 at 8 knots in Beaufort Force 8, that's quite a challenge. So there was a lot of back and forward. Can we actually achieve that? The shipyard were a little bit nervous. Can they achieve it as far as contractually and so on? So we went to Malta, to Flag State, had a big discussion with them and Lloyd's, and agreed that 6 knots is only a guidance, especially with podded propulsion. You don't need that steerage. You can steer the ship basically at just over 0 knots with podded propulsion. So once the shipyard got comfortable with that, we moved ahead. And actually in the tank tests, she was doing 6 knots on one pod, no problem. On sea trials, although the design speed is 12 knots, we actually were sailing along at 16 knots. So she far outperformed her design. Mentioned already the air conditioning, a little bit tricky. We used Kallenberg Trident to do the design of the air conditioning and also the commissioning. Airflow, of course, in the hospital is quite difficult, and also keeping it as energy efficient as possible with the 100% fresh air. That took a lot of effort. The plant itself, diesel electric, fairly simple, fairly straightforward. 4 diesel generators, just under 3 megawatts each. Very reliable, Wärtsilä 6L32s, tried and proven. Nothing too sophisticated there. Waste management was quite a challenge, and I think operationally that's where our work will be cut out, maintaining that thing. I mean, you can imagine all the food waste and everything going through these macerators in the galley all the way down to the pulpers and the dewatering plant and then into the incinerator. I could just see from an engineering point of view a bunch of headaches down the road keeping that all working, but the machinery looks good and it's well thought out, so we just have to make sure it keeps working. On the sewage side, we've got an advanced membrane reactor for cleaning the water. One of our biggest challenges actually in these ports that we go to is water, because we're sitting so long. We have to rely usually on water supply from ashore, and that's sometimes hit and miss, sometimes not a problem, sometimes it can be a struggle. So we're looking at how can we put a water maker on board that will actually make water from harbor water. Now that's easier said than done. I think the water that we produce from our sewage plant is going to be much, much cleaner than what's sitting in the harbor. So we have to think through that one carefully.
Can we dig into some specifics on the ship that directly pertain to its mission, with an overview on the crew, the medical staff, and the number of patients that you can handle at one time?
Yeah, so we have 641 berths on the ship. We basically call everyone crew. We don't carry any passengers. Everybody has a job to do. I suppose staff might be a more appropriate term for the non-marine people, but we refer to them as crew. So there's about 260 of them directly involved in the hospital: doctors, nurses, administrators, biomed techs, and so on. And then everybody else's function is to support them, whether it be in the galley, in the dining room. We have families on board. We have school teachers teaching the children. We have HR department, finance department. We have a cafe on board. Everything you can imagine. So all these people to basically make sure the hospital works. We have, as I mentioned, 102 beds in the hospital, 6 operating rooms, then 90 of these low care beds for people that have to travel a long distance and arrive before their surgery. Maybe they need to be nourished before they can, before they're strong enough for surgery, or maybe they just need a little bit extra time after surgery, and they would stay in these long low care beds. So the ship is designed basically to function as a hospital in port and to have a rapid setup and tear down. As much as possible happens on the ship. On our existing ship, we do a lot of work ashore and tents, whereas we've moved everything on board this ship so people can come on board directly and leave, and we don't have to rely on a big shoreside footprint to do what we do.
Jim, you've obviously been with Mercy Ships for 34 years. What inspired you to join? And I guess what is your greatest satisfaction of the job over the last 3 decades?
The first one's easier to answer. I sailed commercially, as I mentioned, for a few years and traveled the world and saw some real sad spots. I remember being up the river in Guayaquil in Ecuador, and there were people begging for food, and we were throwing them oranges that were about to go bad and that sort of thing, and they were just so hungry. And I got to know my minister back home, and I said, this world just seems a mess. What can I do, to make a difference? And he encouraged me to join an organization. He didn't know any particular one, but maybe you can use your skills in a team that can make a difference. And we heard about Anastasis, our first ship, made application. I thought we would do 2 years and go back home again. Well, here we are 34 years later. What satisfies us? There's so many things. I mean, the most current thing, of course, is taking delivery of that last ship, this new ship. So that was a huge achievement after 8 years. But there's been so many, and often it's the small things that make a big impact in your life. I remember our first trip with the hospital in Anastasis to Mexico. That would be over 30 years ago now. And one of the operations that we do is cleft lip and palate repair. And there was this guy, shoe shine guy in the town square, and our advanced team had befriended this guy. He's 45 years old, kept his head down all the time because he didn't want people to see his deformity. They finally persuaded him to come have the surgery. Of course, the thought of going to hospital in a lot of these countries is a scary thought, because 17 million people die every year from unsafe surgery. So anyway, they persuaded him to come and have the surgery, which was successful. The surgeon that performed the operation, good friend of mine, he's actually still with the organization 34 years later, got a letter from this guy 5 years later. He's 50 at this point, and he was writing to say thank you, and he had just had his first kiss at 50 years old.
No, it's amazing.
I mean, I still remember that 30 odd years later. And so many people that can see for the first time, kids that are born congenital cataracts. And we went to Jamaica years ago. They brought 50 kids from the Salvation Army School for the Blind. 14 of them just needed a simple cataract operation, and they could see for the first time in their lives. No. There's so many things. And I've just come off 10 months in China with a bag load of struggles, but you've got to remind yourself why we do what we do and the difference it makes to so many people. It makes it all worthwhile.
No, well, Jim, it's a pleasure to meet you. It's an amazing mission, and I hope the new ship serves you and the people that you serve very well.